And welcome back. Now today we're going back to basics a little bit because I've been looking at the Arduino forum, some of the questions being asked there, and some of them do start from the absolute fundamentals. So I answered one chappie's question because he wanted to add something into an existing alarm that was on his door, and everybody was saying, whoa, shouldn't touch an existing alarm system, you know, try this, try that. And I'm thinking this is what he needed. Now this is an opto-coupler, that little tiny thing in the middle there. Excuse my fat fingers, I'll use my new pointer. That little tiny 4-pin IC is an opto-coupler, and that could be a real lifesaver if you want to connect your Arduino to some other external equipment over which you have absolutely no control. And more to the point, you're not really sure even what the voltages are or what the ground potential might be. Just because it says ground, or you think it might be ground, it doesn't mean that at all. There could even be some sort of AC voltages there that you're unaware of. This little unit, though, will save your life. So what's it all about? Well, let's have a look at a quick diagram that, in true Blue Peter style, I've prepared earlier. So here we have the circuit diagram of that little chip. So it's this little square box here. And as you can see, there's only 4 pins. Pin 1 and 2 has an internal infrared LED connected to it, and it's up to you to determine what resistor you need here to stop the thing blowing up. And between pins 3 and 4 we have a photo sensitive transistor. So of course when this light shines on here, this conducts pretty much fully. And when I say pretty much fully, what it means is you want the minimum amount of resistance between here and here. Now that won't ever be as good as a MOSFET, of course, but it's good enough for this, for signal processing. And once again, you have to be careful how much current you let down here. So the circuit I've got on the breadboard at the moment is as follows. I've got another LED in series with this one, simply so we can see what's happening. And in fact, you know, it's almost a good idea to have this, I think, isn't it, in a real live system? I mean, why not? After all, if you're building this into a system and something doesn't work, how do you know that this thing here is actually working or not? Well, if you put another diode in series with this one, well, then you'll know it's working, because if this didn't work, this one wouldn't light up either. So you can sort of hone in on the problem. So this data sheet, which I'm just going to show you in a sec, tells us that the forward voltage drop of this diode is 1.2 volts. I know from experience that this one's about 2 volts. So the two together, what we're saying is we want to have a voltage drop here of 3.2 volts. We're supplying it with 5, so we're dropping 1.8. I'm saying, at a guess, 5 milliamps should be enough. 0.005 of an amp, that is. So 360 ohm resistor here is what we need for this bit of the circuit to work. Well, as it happens, I haven't got a 360, I've either got a 330 or 390, so I'm erring on the side of caution here. I thought, well, we'll try a 390 first and see what happens. And on this side, I've got a trusty LED that I know works, well, basically without a resistor anywhere, because the voltage drop is quite high. But I've put in something like a 68 ohm resistor anyway, just to ensure that we don't start blowing this up. So that's the two halves of the circuit. And as you can see, these two halves are totally and utterly isolated. This bit of the circuit knows nothing about this bit of the circuit. And even though I've drawn in the fact that this is going to ground, these grounds do not necessarily have to be connected, and indeed should not be as far as your circuit's concerned. So for example, the chappie asked about the alarm. If he could get a signal from here, from his door on the alarm, all he needs to do is break into that circuit, run this into it, and that bit goes back into his system. And the Arduino then knows nothing about that bit at all. Okay. So as you can see at the moment, there is no Arduino involved. This is just to prove the point that we can get something working. So let's have a look at the workbench and see how this stands up. So what I've got actually set up here is the chip as described in that diagram, with the LED wired in series with it, so we can see what's going on effectively. There's the limiting resistor, which was 390 ohms. See, we can read these ones nice and clearly. And there's just a switch in series with that resistor, so that this switch controls the power to this half of the circuit. Now this half of the circuit, we've got this LED and a limiting resistor, which we don't really need for this LED, but I've put it in anyway to protect the chip more than anything else. So this bit here is doing nothing other than supplying power to this half of the circuit, and this half of the circuit is powered independently. So when I now press this button here, so this LED goes on to show that we are actually allowing current to flow through this half of the chip. Yes, it is one of those flashy LEDs that came with the Christmas tree kit. Very nice too. But this bit here simply shows that current is flowing. If I just bend that down a bit, because it's not as bright as otherwise it might be. Right, now because that's the interesting effect actually, because this one actually switches off and on occasionally, that one is sort of mirroring what's happening over here, which proves wonderfully well that this chip does communicate across that bridge, if you like, exactly what's going on. So the current flowing down here determines what current flows over here. So that's a pretty good demo actually. Now, just in case you're still confused about the second half of that transistor, if we look at this again, if you consider this one here, yes, this is a photo transistor, but maybe it's not quite clear what this bit is doing. So let me just take myself off the screen here for a minute so I can draw on. If I draw that second bit again, pin 4 is here and pin 3 is here. Instead of a transistor, if we assume that is more like a switch like that, and that switch is controlled via the diode coming in on the other side. So there's the diode sending out its little rays, but those rays effectively push or shut this switch here. So normally it's open, and when this current flows in this direction, this switch shuts. That's all that transistor is doing. We're using it as a switch. There's no linear mode that we want to use on there at all. It's purely on or off. Okay, so that's really how you have to imagine this bit of the circuit, like a switch between pin 4 and 3. However, there's not unlimited current through here. In fact, we'd have to go to the spec sheet to find out what current we can expect to flow through here. So let's do that next, so we don't go and destroy our chip accidentally. Right, this is the now the Sharp PDF. This chip is in fact made by Sharp. Now the numbering here, this 1 indicates how many of those diode transistor gates there are. Now on this one here we've only got 1, so it's an 817, but you could have an 827, an 837 and an 847. They're all built into the same chip like that, so depending on how many switches you need, you can just buy it in the one single package. But for this demo we've only got 1, so it's an 817. Let's have a look. Now we don't need any of this. That's how the physical thing is. There are the marks on it. Here we are now. Absolute maximum ratings. That could be quite useful. So we're saying forward current. This is on the input side now. So this is the diode side. Right. Maximum 50 milliamps. Peak forward current 1 amp. Well, that's probably for about 1 nanosecond or something. In fact, it does say it over here. Look, 100 microseconds. That's not a lot, is it? So 50 milliamps maximum. I think we've got about 5 milliamps in our little setup here running through there, which is more than enough, and it works. Reverse voltage. Now this is, you have to be careful here. Look, the reverse voltage here is only 6 volts. Now 6 volts is only just a tad below what your Arduino give out. So if you connect it the wrong way, it should survive that. But if you're powering, say, from 9 volts and you're using 9 volts, or your external device, your alarm system or whatever it is you're connecting to that side, just make sure you don't connect it around the wrong way, because 6 volts isn't a lot. In fact, I would suggest at that point, I don't know why it's so low, diodes normally are higher than that. I would in fact suggest, if we just go back to the workbench for a sec, given that the reverse breakdown voltage is so low, I would recommend putting a diode anyway. If you don't want one that lights up, certainly put one in series here, just a standard diode, not an LED necessarily. You know, a 1N4001 will be absolutely fine, so that current can flow one way but not the other, and therefore that has a reverse voltage much higher, probably about 50 volts or something, so it'll protect that. So if you're not going to have one of these LEDs in here to show you what's happening, at least put one of those in. Okay, let's draw it properly. Trying to draw this on camera is really difficult because there's a slight delay between what I'm seeing and what I'm actually doing. Anyway, so there we are. I'll just put that protection diode in. I mean, you can put it in anyway, really. It's a pity they haven't put something in series with this anyway inside the chip to protect that diode, given it's such a low reverse voltage. Anyway, back to the data sheet then. Right, what else does it show us here? Let me make this a little bit bigger. We can always scroll down, can't we? So we're saying, right, the reverse voltage is 6 volt, maximum power dissipation 70 milliwatts. So it's all right having 50 milliamps, but you're soon going to reach the 70 milliwatts, aren't you? Now the output, that's the collector side then, the transistor side. Maximum of 80 volts, well, we're not getting anywhere near that, are we? Emitter collector voltage, that's a reverse voltage again. Once again, it's 6 volts, so we have to be careful about that, I think. Collector current 50 milliamps, we don't need anywhere near that amount for Arduino use. And 150 milliwatts. So don't think about driving any relays on this, because I don't think that's going to be on at all. So just be very careful with this and treat it with a little bit of respect. The trouble is, of course, you see, with being embedded in that chip, you're not going to know when that component breaks down. You know, there's no LED visible through it. So I would say caution with this. Right, what else have we got on here? Electro-optical characteristics. Okay, forward voltage, right, 20 milliamps. Here we are. Look, the forward voltage is 1.2 volts, maximum 1.4. So it's very low, actually, very low indeed. Peak. Oh, the peak forward voltage maximum is 3 volts. So once again, it's all a little bit, well, I hesitate to use the word delicate, but I certainly wouldn't abuse this product at all. Certainly put in some protection yourself, whether it's diodes or decent resistors or something. So output, collector, dark current. Dark current means when you haven't got the LED internally lit, it's going to be 100 nanoamps. That's pretty small. Breakdown voltage, we don't really care about that, do we? Collector current, right, so the collector current with a forward voltage of 5 milliamps, VCE of 5 volts, is maximum of 30 milliamps, which is, that's pretty high, isn't it? 2.5 milliamps, that's much more reasonable. So basically what it's saying here is, if we go back to our little diagram, for Arduino use, I think we're going to have a much bigger resistor here. I would say 10k at the very least. You probably get away with a lot more than that, because if we're simply detecting voltage at this point here, or this point here, I should say, really depends if you put a resistor in here or not. The Arduino is going to detect it at a much lower current than what we're using for this demo with the LED. In fact, when you think about it, the Arduino's input pull-up resistors are something between 20 and 50k. So I think we might stick something reasonably high here. This side's okay, but as I say, do work out the voltage drop in the same way as I've done here, depending on what you're putting in at this end. I mean, we're only using 5 volts here because I've got it plugged into a USB phone charger type socket, but say that was 50 volts, then you'd have to be very careful about what this resistor is here. And as I say, start high and work low before you destroy this chip. Okay, I think that's probably enough theory, and you've seen it working sort of in isolation mode. Okay, so what's happening over here happens over here, but by virtue of light traveling between the internals of this chip. That's all well and good, and it all works nicely, but really we want the Arduino to respond, don't we? So let's wire this up a little bit differently now you've seen it working, and we'll get the Arduino to respond to current flowing through this chip. So rather than lighting this up directly from here, we'll get this thing lit up from the Arduino and have the Arduino detect the fact that there's current suddenly flowing through this half of the chip. As I say, the Arduino doesn't need to know anything about this half at all over here. That's the whole point really, and we certainly don't even want the grounds connected. Okay, let me wire that up and come back to you. So what we have here now wired up is the Arduino geared up to detect voltage at the input of this other half of the circuit, and I'll show you that diagram again. So what we're doing, we're putting a pin on here on the Arduino going, is there voltage here? Well, normally the answer would be yes, because we're connecting this to a power supply here. Even though we have a high resistance value here at the moment, and I've chosen 47k, I'll draw this out again in a minute for you. I haven't put a diode in there, of course. So at this point here we're going, is there voltage? Well, yes there is. It's only when this light is emitted in here that turns this transistor on and effectively brings it to earth does this voltage here drop to earth, like this switch. Alright, so it's the same as this. That closes when that lights up inside. So pin 4 is then shorted effectively to earth, and because we've only got a 47k resistor in here, the amount of current flowing through there is tiny. So that works as you would expect. I press the button, and so when there's a light on here, there's a light on here, it corresponds exactly. And because I'm using one of these fancy Christmas tree lights that flashes and pulses and does all sorts of things, this follows suit. So if this were a signal of some kind, I don't know what, but there could be something. If this were a signal, you know, on, off, whatever, this replicates that rather nicely. And of course the two halves of this circuit never ever touch, not even in their grounds. Okay, so this half of the circuit is entirely separate from this one. And remember, this LED here is only in here, as I say, for convenience, so that we can tell that something must be happening inside this chip, because if this chip wasn't conducting, then this LED would not be lighting up either. Right, so let's have a look at the equivalent circuit now, what I've done here, which is simplicity itself. It's no more than the blink sketch really in complexity. So let me show you that on my workbench. Right, so there's the code. Well, I can make that a lot smaller, can't I now? Let me just... Right, okay, so what we're saying is then, so we've got an LED pin, that's the pin that's connected to the output LED, this one here, the pink one. Okay, so that's the LED pin that the Arduino knows about. And the input pin is the one we've connected up here at the junction of pin 4 and this resistor. So what we're saying here is, if the voltage on that switch pin is high, it means that there is no light being transmitted internally in that chip, therefore nothing's happening. So we don't want the LED lit, so it's low. On the other hand, if the switch pin is low, then we want the LED to light up. Okay, I'm going to draw that out in a little circuit just to make it absolutely crystal clear, because I know there were quite a few queries on this subject on the Arduino forum, so it's better to be clear, isn't it? Right, I'm going to go into speed drawing mode, and then I'll sort of narrate over the top of it later. Right, bear with me. Right, there's our PC817. We're going to deliver the voltage into there via a 47k resistor, which we can detect on pin 7 on our Uno. So that goes to ground there. Now the output from the Uno via a resistor to an LED to show that it's detected the voltage. Now that acts as a switch, so I'll draw that in there. And the other side, of course, via a resistor and a protection diode this time to the internal LED. And I would suggest working out that resistor value depending on your input voltage on that side of things. Now those two bits of the circuit are totally separate, and that's your opto isolator. And that is it. I mean, it really is that simple. But it could really save your Arduino from anything coming in from an external system that you have no control over. And of course, it stops you then playing about with that external system, whether it's some kind of machinery, a motor, an alarm system, some kind of, I don't know, voltage detection you want to do. Whatever it is you're doing, it's best to separate the Arduino from anything else that's happening over in the non-Arduino world, and that little tiny chip in there could be your lifesaver. As I say though, treat this with respect. This particular one has a reverse voltage of 6 volts, so you don't want to be playing about too much with the wrong polarity on that. But if you stick a diode in series with pin 1 or 2, I think it'll be safe. And ditto on this side. Remember that it's only got a reverse voltage protection on that side as well. Sorry, just looking for my pointer here on my fat finger. So the reverse voltage here of 6 volts as well on this side, the transistor switch type side. So a nice little 1N4001 on there could also save that from inadvertent well, excess reverse voltage. 6 volts isn't a lot, is it, when you think about it? But it is enough for a 5-volt Arduino, so if you did do it wrong on there, at least it won't blow that chip up. Okay, so that's the simple little thing, and it works like a dream. Look, no problem at all. I like the fact that this chip, well, this LED has a built-in chip, so of course it's doing its thing with all these little pretty colours and things. And as I said in a previous video, it looks a lot better in real life than it does on here. And this one here is actually replicating what's happening over there when it goes into flashy mode rather nicely. So at the moment it's fading, now it's flashing, and that does exactly the same. So good for sort of signal transference as well, really. I don't know what the maximum frequency transfer is. In fact, why don't we have a look at that on the data sheet again. Cut-off frequency, hang on, let me get rid of my workbench picture. It says 80 kilohertz. Not that fast then, but could be fast enough for some things. Maybe I don't know, an optical sensor for a motor or something, if you're detecting spin speeds or something like that. So it could be quite useful for something like that. But I thought it might go up to the megahertz, but it doesn't. Okay, not to worry. Still very useful, absolute lifesaver, great. Now, just before you go, don't run off, there's more. This was back to basics. But if you remember my Christmas tree project, which hasn't arrived yet incidentally, so I haven't made it, don't get excited. But there was a question on my YouTube video part which says, can you give me a sketch for an RGB LED? And I says, well, I can't do it there and then, but let me experiment. And I have been experimenting. Now I've had to change the code in the Arduino, which I haven't even published yet, so you don't really know what it's doing. But I just want to demo it to you very quickly, what happens with an RGB LED when it's driven from a sound-to-light source. So stand by, I'm going to replace this with my other one, with it all set up. It looks very pretty, it's worth 30 seconds of your time. Back in a jiffy. Right, here we are. Now I've got this set up with the two-stage transistor amplifier here, so obviously it's picking up my voice at the moment. And what I've done is change the code. Where's my pointer gone? Let me use my pointer rather than my fat finger. So I've changed the code now so that this RGB LED, which does come across on camera quite well actually, only displays one of the colours when it detects sound. That is to say, it picks up the sound of my voice, or indeed the music or whatever, and it tries to light up one of the colours as RGB, red, green and blue LEDs built into this little unit here. However, if one of the LEDs is already lit, then it just has to give up. It doesn't do it. It goes, oh no, the red's already lit, I won't light up the green one. And it goes around the loop again, and we're talking thousands of times a second here. So it goes, right, I've detected more sound, can I now light up the blue one? And it goes, yes you can, because the red one has now gone off. So what it actually does here is cycle between, well, not necessarily between, it's not round robin, it's purely random, whatever's next. So the red, green and blue all get an equal share of what to display. Oh no, that was quick. Well, I did say 30 seconds, didn't I? Okay, that's all we got time for today. Remember that Opto Isolator, that could really save your project. And this one, start preparing for Christmas, because I'm recording this in September. Christmas will be upon you before you know about it, and you can build that Christmas tree project or something like it very, very quickly and impress your friends and family. Okay, that's my advice for the year. Marvellous. Okay, great stuff. Don't forget to share, spread the word, thumbs up, and do subscribe if you haven't subscribed already. Okay, thank you very much. Thanks for watching. See you in the next video. I hope you're finding these videos useful and interesting. Please leave comments down below. Subscribe, share and give me a thumbs up. Thanks for watching. See you in the next video.